were to do that off your engine start battery, you are going to pretty much destroy it very, very quickly. It's not LED. It senses the voltage on these batteries, and once it gets to a predetermined limit, you'll see that the relay breaks open, and it always have an always-on circuit, where basically these circuits are wired straight up to the domestic batteries. All these different devices, you will have some sort of smart charger here that basically regulates the current, so your batteries are getting. If you've got things like electric winches and a windlass, so I'm Alan, and I do sort of content creation for Ardent, and tonight I am going to talk to you about batteries and electrical management systems. Sorry, I am a bit croaky. I have got a cold, so you'll be very glad that you're at the other end of the internet, and I've got my trusty roll of tissues with me to help me through, but I'm a bit croaky. The first thing and most important thing I will stress straight away is I am not an electrician. I'm not a qualified electrician, so take everything with a pinch of salt. But what I am is a boat owner, and I think for many of us, if we are boat owners, then we take on the role of being many, really, a jack of all trades, master none. And so as a boat owner, I am the electrician, and I'm the plumber, and I'm the fiberglass guy, and I'm the sail repair guy, and the plumber, and I'm the navigator, and I'm the chef and the doctor and the dentist. To be honest, this is what I like about sailing, is that really, if you've got a boat, you kind of have to get involved in everything, unless you've got very deep pockets and you can afford to pay for lots of professionals. So this is very much from my point of view, and I thought the best way really of presenting this was really to talk about my experience with my boat and how I set her up. So my boat, Fair Exchange, I bought her, crikey, over 20 years ago. She was already 35 years old now. She's an old girl now, 55 years old. And pretty much when I bought her, nothing had changed since she was built. It was very, very basic. And as I was planning to spend sort of 4 or 5 months every year aboard her to go cruising, I needed to make her sort of comfortable for living aboard. And I kind of went through the electrical system of the boat. And what you can see here, my little overview here, is the sort of things I did to the boat to get her up for cruising. So let's have a look. As I said, I'm no expert, so hopefully you're not going to ask me lots of technical questions. But let's start with the basics. Small boat, my boat's 37 foot. We need power. These are going to come from batteries. And I've got the two main batteries you're likely to find on boats. Lead acid batteries have been around for a very, very long time, kind of low tech. More modern, we have gel batteries. They come in different flavors. Again, I'm no expert. AGM is classically known, but there are various types of AGM batteries, and there are all sorts of other things around. Lithium-ion batteries are very, very popular, but I am slightly nervous of them, as they do tend to explode, and there's a lot of problems with them, especially on boats. But fundamentally, from my point of view, lead acid batteries are the sort of batteries you might well find in your car. They have metal plates in, lead plates, and they've got an acid in them to chemically produce electricity. The AGM, the gel batteries, are the similar thing, but the acid is held in a gel between the plates, and basically the difference is they are completely sealed, so zero maintenance. And you may think that the gel battery is a preferred option, especially on the boat, and to some extent it is, but of course there are pros and cons to each. Gel batteries are great, zero maintenance, and you can mount them however you want. They won't spill. You can mount at any angle, whereas your lead acid batteries do have these vents along the top. They do have sulfuric acid in them. You do need to treat them with respect. So why would you go one for the other? The honest reason, lead acid batteries, though they're fundamentally very basic, is you can maintain them. And that's the attraction for me, is that I can look after my lead acid batteries. I can top them up with a liquid and keep them going longer. I can charge them harder. Whereas gel batteries, they are completely sealed. You can't charge them quite as high. And they also tend to be more expensive. But the choice is yours, really. If you want a low maintenance battery, then maybe the AGM's way to go. If you've got some electrical knowledge, you might think that lead acid is possibly a preferred option. Now, not all batteries are the same. In my little example here, I've got two batteries. One I've classed as engine start, one is domestic. They are different batteries doing a different job. Your engine start battery, and you might just think about your car here. Your battery in your car only has one job, and that's to start the actual engine. Basically, as soon as you turn the ignition key, it fires up the starter motor, the engine starts, and that is it. Because once the alternator is running, all the electrical power is then from your alternator. That runs all the systems on your car. So the battery only has to start the engine. It uses an immense amount of power to start your car with a starter motor, and so your engine start battery is designed that it has a lot of very thin, large surface area plates that are able to give a big punch of power for a very short period of time. You know, most engines will start within 2 or 3 seconds, and that's the same on your boat. The problem is that if you've got a boat, and especially a sailing boat, is that once you're actually away, you switch your engine off and you start consuming power from your batteries. You're using your power to run your radio, your chart plotter, or your lighting systems, all the sorts of different bits and pieces. And if you were to do that off your engine start battery, you are going to pretty much destroy it very, very quickly. It's not designed for that sort of work, taking lots of power out. And so you'll find that we do have these domestic type batteries, which is basically the same technology, but they are much, much heavier built with big, thick plates, and they're designed that they can be discharged heavily, charge them up, discharge, charge them up. This one actually says, I think on the side, it's got over 80 cycles of charge, discharge, charge, discharge. And so they're designed to be deep cycle batteries on your boat. Now, a small boat, you might just have one battery, probably a deep cycle, but many boats, probably over 30 foot, I would suspect you'll have a dual system where you have a battery that's just used to start the engine, and that is it. And then you have a domestic system for running all your boat systems. And you may well have multiple. On my boat, for example, I've got 2 domestic batteries that are parallel together to give me the power for all my equipment. Maintenance, well, obviously, if you've got a sealed AGM type battery, there is 0 maintenance to apart from keeping charge, which is nice. If you've got a lead acid battery, as I have, then there is some basic maintenance. The battery is full of sulfuric acid, and as you charge the system, this acid is used up. So there's a couple of very important safety features. When you are charging these batteries, they are producing both hydrogen and oxygen. Hydrogen, of course, is highly explosive. Oxygen burns really well. Now, in your sealed battery, that's not a problem because the gases can't escape. They're held within the casing. But if you've got a vented lead acid battery, then you have got these gases coming out. To be fair, it is not extreme. On a larger boat, you may well have your batteries in special boxes, and those boxes may well have a electrical fan that is venting the battery box to keep the gases clear, so there's no risk of any sort of explosion. I have to say, on my boat, my batteries live under one of the side benches on the boat. They just sat there. They charge and discharge. I've never had problems, so I wouldn't get too paranoid about venting, but many boats will have a venting system just to take those dangerous gases out. As you're charging the battery, some of the sulfuric acid will be used up, and so this is the nice thing of lead acid. You can maintain them. You can see I've got a little picture of a distilled water bottle here. And that's what we put. If we've got lead acid batteries, then you will use distilled water just to top up the liquid, just so that if you looked in through those vents at the top, it would just be covering the plates. And it's just sort of a monthly check just to make sure that there is enough liquid within the battery. Winter maintenance, just worth a mention that you've got some quite clever smart chargers for boat batteries, or all sorts of batteries these days, which you can pretty much switch on and leave them to it. I'm very much a believer that the battery should be allowed to sit over the winter months. And so what I do is I have my batteries completely off, and then once a month I put my battery charger on for 24 hours. It gives it a little hit, brings it back up, and I switch it off again for another month. So it's your preference. I leave my batteries on the boat. Some people bring them home, and my only sort of word of warning there is, especially if you put them in the garage, make sure they're going to be warm enough. You really don't want to freeze the batteries, and I'd certainly put them on maybe a couple of bits of wood or a bit of carpet. And if you are expecting really sub-zero temperatures, you should bring them inside. But I'm very lucky where I live in Cornwall. It's very rare that we get very low temperatures, so the batteries are quite happy on the boat. Your battery's rated to how much power it can give you, and these are called amp hours. And when you buy a battery, you will work out how many amps you require for a battery. Basically, the way I perceive it as an amp is a kind of a unit of power that you can consume, and different bits of equipment will use different number of amps per hour. So we'll talk a bit later on about, you know, when you are preparing the batteries for your boat, thinking about how much power you need to actually run the boat successfully, depending on how much equipment you have on board. This little picture is 120 amp hours. I think my boats, I've got two 100 amp batteries. So I've got 200 amp hour batteries. Unfortunately, battery technology is extremely complicated, and so even though this battery is rated as 120 amp hours, you do not have 120. In fact, you're very lucky if you can use about 50% of what's in the battery. So typically, if I've got a 120 amp battery there, then by the time it's 50% discharged, I've used 60 amps from it, it will be pretty dead. So don't think because a battery is rated at 120 amps, you've got 120 amps available to you. And just to make it more complicated again, then when you come to charge it, then just by putting 60 amps back in does not bring it back up to full charge. You need more than that 60 amp hours, and I'd be guessing maybe 10 or 20% more. So you put more power into it. So it's not quite straightforward. It's not a very simple calculation for working out how much power you've got available to you. Okay, quick word about electrical systems. On the left, we've got this earth return system. This is pretty standard. You'll find on a car, primarily because 95% cars are made of metal. And what that means is that you can have the positive lead that runs out through a variety of switches to all the equipment on your car, and then the negative is all read through the actual shell of the car back to the battery. And it's a cheap way of doing it. You use thinner wires, it's a lighter system, you save money, and it works really well. On a boat, firstly, it tends to be more difficult than that because most boats aren't made of metal. Some are, but most boats will be fiberglass or wood. So you can't have that return system through the hull. And secondly, and more importantly, it is not good for a metal boat, because if you have a steel boat or an aluminium boat, because you're in a saltwater environment, if you start passing a current through the hull, your hull is basically going to dissolve through electrolysis. It's a real problem, especially on aluminium boats. And so on boats, we have a negative return. In other words, we have a positive lead that runs to the equipment, and then we have a negative lead that runs back to the battery. So we have doubled up the wiring because we do not want stray currents running through the hull of a boat. Okay, this is pretty much the master switch system. When I bought my boat, this is very common. You'll still find this on some of the old school boats that are around. And pretty much you've got this switch here. You'll see off, 1, 2, and both. And typically your battery number 1 leads to an engine start battery, and your battery number 2 leads to your domestic deep cycle batteries. And this is how my boat was and how many boats are. And the way this works is that when you get on your boat, you flick it to the 1 position. That means the engine start battery is connected. You start your engine, the alternator is now charging, and that is pumping power. But because the setup, it's now pumping battery only into your engine start battery, which is fine. But of course, you need to charge your domestic battery. And so you need to remember, having started your battery, your engine, to put it now into both. So in the both mode now, it's charging both the engine start battery and the domestic battery. And that's fine until you come to stop the engine. This is a problem more so on a sailing boat, because once you've actually got out of the harbour, you put your sails up, you start to sail. And if you have left your switch in the both position, you're going to find that it's now discharging from both the batteries, and it will bring them down and bring them down. And if you forget and you leave this on both, then you may have a situation where you flatten both the batteries together. And so when you come to want to start the engine, of course, the engine start battery is flat, you can't start it. And so with this system, you need to remember that once you start sailing, you put the engine off, you need to flick it into the position 2 on your boat. And now that means it's drawing current from your domestic battery. And even if you completely flatten this domestic battery, then your engine start battery will remain full, and you can always start the engine again. This clearly is a bit of a pain. And that's one of the first things I changed on my boat. And you have got these rather nice little dual charging systems. And this is what I fitted on my boat to relieve me of this problem of knowing which switches to switch when. On the left, we've got a solid state diode device. And on the right, we've got a relay. And they both do the same thing. The solid state relay is kind of attractive because it is solid state. There are no moving parts. But because it's got diodes, you do get a voltage drop, and that basically means your charging efficiency is not quite as good, because you're losing a little bit of voltage by using this device. I fitted on my boat one of these little BEP digital relays, mechanical relay in it. There's no voltage loss. The argument, of course, it is mechanical and it could fail, which is a fair comment. But I will say that I've had mine fitted on my boat now for about 20 odd years, and it's worked perfectly. So I'm really happy with that system. So what does it do? Well, it's a clever little thing. Here is my battery system. I've got my engine start battery, my domestic battery. I've got my little key switches on each of those. And basically, when we start, when I put my engine start on and I start the engine, and then the alternator automatically is feeding current through into the engine start battery, and basically it senses that battery until that battery is full, which doesn't usually take very long, because if your engine starts pretty quickly, it'll only take a matter of minutes. So once it senses that the engine battery is full, it then joins the two together with a relay and now starts charging both of the batteries, the engine and domestic. And because the engine start battery is full, the domestic gets the bulk of the flow. When you come to stop the engine, as I imagine we're going sailing, then initially the alternator is stopped and we start to discharge. But again, it senses the voltage on these batteries, and once it gets to a predetermined limit, you'll see that the relay breaks open and it disconnects the two batteries. And so now we're drawing current from our domestic system, but the engine battery is completely disconnected. So we can theoretically completely flatten the domestic system, and we know that the engine battery will always start the engine. So it's zero maintenance. Basically, you start the engine, you run it, you switch it off and on as you require it. You do not need to think about changing switches. Perhaps worth mentioning, many boats you usually have a domestic switch here, an engine one. You do have this both. I've got one on my boat, because if you do step aboard the boat and you find that your engine battery has gone flat, you do have this facility that you can manually join the two batteries together and use your domestic battery to start the engine. And once it's started, then you can take the the relay out and go back to normal charging. So that's why I fitted my boat, and it's worked perfectly for the last 20 years. So I'm very happy with it. A little word about cabling. This is really just to say, when you are fitting equipment, you do need to make sure you have adequate size cables. If you use cabling that is a bit too small, it can get hot. If you're drawing too much current through it, it can start to melt. It can cause fires. But before you get too concerned, on most boats, the power consumption of general equipment is quite low. And I'm looking at these very smaller cables at this end, and you'll see here, they consume something between 3 and 5 amps. Well, a lot of boat equipment just really isn't drawing those sort of currents. So even the smallest wires are more than adequate to run your kind of instrumentation, your radios, your lighting system. So I wouldn't worry too much about it. It's the big stuff at the other end. And it's, if you've got things like electric winches and a windlass, these are going to be the big power consumers. And certainly if you are wiring up a windlass for your boat, you do need to start going for these very big cables that are drawing large amounts of current. But I would say generally, most equipment on your boat will be quite adequate with these very small cables. A little word about cables. This is classically, this is copper strand. We don't use household cabling on a boat because it's a single strand of copper and it can fracture. So we use stranded wire. That's fine. This is copper. You will find that standard cabling copper wire, if you've got a boat that's been around for a long time, you will get this oxidization on the actual copper. It kind of goes black and makes a very poor contact. If you have the money, then we get what's called tinned wire, where the copper is coated in a layer of tin. It's a lot more expensive, but it's pretty bulletproof. And if you're doing a complete new wiring for your boat, tin wire is a big expense, but you will find the cables will not corrode as much. Having said that, again, on my boat, I fitted cabling, just regular copper cabling, and even after 20 years, most of it is in pretty good condition. It has to be pretty old and exposed to get that kind of oxidization on it. But if you have the money, tin cable is nice. Connectors, whole variety of here. The big battery stuff, if you've got cables to electric winches to windlass, you need these big kind of crimp on. These go into big fat cables. This is clearly designed to go into the post of the battery. Most of my electrical wiring on my boat, I'm using these small crimps, which are easy to get hold of, a whole variety of shapes and sizes. Some have got heat shrink on, which are really good to keep the moisture out. You can see these ones here have got the heat shrink there, which is really good. I have many terminal blocks like this, where I think they're generally called chocolate blocks, where you just put the wires in and use a screwdriver to crimp them down. And I've also got a combination of these are sort of fairly modernish, but these are reusable connectors. You lift the little flaps here, poke your wires in and lock them down, and you can connect one wire to multiple wires, a whole variety of different types. And they're quite expensive, but they are reusable. They're quite nice. So I've kind of got a combination of all these on my boat, but I suspect Crimps is probably the one that I use more than anything. So your power from your battery, your domestic battery, is going to come into some sort of switch panel. Two nice little examples here. On the left, we've got a classically fused panel. We've got these electric switches, and we've got independent fuses down the side here. This is a sort of system I have on my boat. Most modern boats actually have these rather attractive breakers on them, and these are like little magnetic breakers. They have magnets in them. When you flick them across, they engage and they stay in the on position. But if you exceed the current they're rated for, the magnetic switch breaks and they flick back off. So they're fully reusable, basically. For me, I have to carry spare fuses in case I get a problem with the system. But breakers, you can always switch off and on. And if you've got a fault, once you've fixed it, they will come back on. They are expensive. That's why I still got a fuse box. I've always sort of lusted after a breaker panel, but I'd be guessing. But a panel like this is probably going to cost me £300 or £400, so it's quite a lot of big investment. Whereas my switches actually work perfectly well. And perhaps worth noting, see on this panel here, we've got a little voltmeter, and you can flick this switch between motor and auxiliary, so you can actually check the voltage on both your engine start and your domestic system. And you've also got this one that's measuring current, how much current is being drawn from your battery. Worth mentioning, always on circuit. So basically the cabling from your battery goes to your panel, and from the panel you can switch stuff off and on. And I was always taught from very early age, when you leave the boat, you switch all the power off. And of course, that's fine, apart from when you need stuff to be on when you're not on the boat. And I guess classically, you might think about an automatic bilge pump, where you want it when you're away from the boat. You want this bilge pump that's sitting down there to sense if there's water collecting the bilge. And if it does, then it wants to pump out automatically. Now, if that was through the switch panel, of course, it wouldn't operate if the batteries are off. And so we always have an always-on circuit, where basically these circuits are wired straight up to the domestic batteries, regardless of whether the main breaker is on or off. Some examples: automatic bilge pump makes sense. For me, my fridge is on that circuit, because when I leave the boat, if I'm at anchor and I go ashore for 3 or 4 hours, I always put the power off. I don't want anything on the boat, but of course I want my fridge to keep operating. So my fridge is on an always-on circuit, so it keeps running. And some boats will have some sort of alarm or monitoring system. A lot of people are fitting systems that use 4G, so they can actually act as alarms, or even give you video feed of the boat, or give you temperatures, all those humidities. So these systems need to be on while the battery's kind of been left in the off position. And so you will often find an always-on circuit that bypasses the master switch, and means you can keep this running. Notice I have just shown you've got these fuses. You don't really want to have this equipment directly onto the battery, because if there is an electrical fault, you could cause a fire. So these will all have an independent fuse on them, and may even have a switch, so you can switch them off and on. Monitoring your battery, pretty common on a lot of boats. You will have some sort of voltmeter. To be honest, I don't find them particularly useful. They're just giving you the voltage of the batteries, so you've got some idea whether they're maybe being charged or not, but they're fairly inaccurate. Preference-wise, I prefer more of a digital one, because you can see a bit more accuracy there. We've got 12.5 volts. It'll be very accurate to see where that sat on this manual meter. And I like this one here because it's also showing the current. So that's showing how much current is being drawn from the battery as you put the equipment on, or indeed if the engine is being charged, how much current is going on. My personal preference is to have more of a battery monitor, and there's just a couple of examples here. I've got one of these BM1s, and it's a bit more clever. It is showing you the voltage, it is showing you the current draw in and out, but it also kind of counts. It's like counting calories, I suppose. It counts amps. So it counts how much current is being drawn out and how much current is going back in. And that's how it's able to give you some estimation of the percentage state of your battery, whether you are making current, or, sorry, losing battery power or making more. So it gives us some indication of how much is available to us, because it knows what's been put in and what's come out. I would say mine is not particularly accurate, but it's better than nothing. The Victron, which is a much better manufacturer, much better make, is a far more accurate. The algorithms it uses are far more accurate to give you a better idea of the battery condition. And certainly, I'm sure there are other manufacturers around, but this is the sort of thing I would look for now to give me a better indication of the actual state of my batteries. And there's mine in action, 13 volts and charging with almost 80% in there. Now, a lot of this about batteries, it is about power consumption. Obviously, you can have lots and lots and lots of goodies on your boat, and they're all using power. My policy has always been the reverse, is about trying to use the least amount of power. And this is just a good example. Bulbs, and this is was for a game changer for me when I bought my boat. And these are just loose figures, so don't take too much on them, but this is a classic filament bulb. And I'm thinking, if I'm sailing overnight and I've got my tricolour on for my night sailing, then in the old days I'd have my classic filament bulb on, which is consuming between 3 and 4 amps an hour, compared to a modern LED bulb, which is more like 0.2 of an amp. And if you just do the maths, there you go, then you can see that if I'm thinking during the summer months, if I'm overnight passage, I'm sailing for 8 hours overnight, if I had my old filament tricolour on, I'd be consuming 32 amps. I mean, that's a whopping great load I'm taking out my battery just to run that one bulb. And yet, if I'm using my LED, you can see overnight 1.6 amps. And really, as these LED technologies improved, I have actually replaced every single bulb in my boat, inside and outside, with LED. The amount of saving is absolutely huge. And was before I was always a bit paranoid, switching off lights left, right, and centre. I'm happy to leave bulbs on because they really are not consuming much power at all. So you do need to think about how you can save power on your boat. An inverter is a useful feature because sometimes on a boat we do need 240 volts AC. I rather kind of strange putting a coffee machine here. I'm not quite sure why. I certainly couldn't run a coffee machine on our boat, but I have got a small inverter, and it means, most importantly, is that I can charge up my laptop, I can charge up my phone, I can charge up my cordless drill, and a few other small cameras, small items that need 240 volts alternating current, that you need to charge off an AC side. And this is what an inverter does. It converts DC back to AC. Coffee machine is probably unrealistic. It's got a heater in it. You would have to have a flipping very large inverter to run something like that, or you need a kettle. I think to run a kettle on a boat, you need 2,000 watt inverter. And to do that, that's going to drag power out of your batteries quite a lot. But I think the one on my boat's maybe only 200 watts, and it does charge the laptop, it does charge the power drill, the cameras, and those sort of items. So it's nice to have that ability to get 240 volts into your boat. Again, take these figures I kind of drew from my head. Don't go for accuracy, but it gives me some idea. This is a little calculation you might want to do on your own boat. So I've worked out typically how much current each item is using, and that information you'll often find in the manual. You can find it online, and then you can multiply that out by how much you think the equipment will be on during the day. And I've just sort of guesstimated at some of these figures here. My fridge, my chart plotter, autopilot's always a very big current draw on your boat. Instruments, I've still got manual instruments, which are quite low power consumption. A lot of the mod instruments I've got LCD displays, color displays. They're like mini computers. They will use a lot more than a basic analog instrument. But this is not untypical for a boat like mine. 37 foot, 90 to 100 amps per day is what my typical consumption is when I'm sailing. So of course I need to think about making sure I've got sufficient batteries to allow me to draw that sort of current. And when you think, I said we'd only have, if I've got a 120 amp battery, I can use half of it. And that's why on my boat I've got two 100 amp batteries. That's 200 amps. I can usefully use 100 amps of that, which will cover my daily needs. I put the windlass separately because this is a big power consumer, and some of you may have mechanical windlasses. When I broke my mechanical windlass, I did fit an electrical windlass, which has been great, but it is a massive power consumer. The motors within this are similar to the starter motor on your engine, but whereas your engine, you only turn the starter motor over a few seconds. If you're pulling up 50 or 60 meters of chain, this is going to be running for a number of minutes, and it will drag power from your batteries. And the setup for these, there's two basic ways of setting this up, and this is one where you have an independent battery for your windlass. So you've got your engine start battery, you've got your domestic, you've got your, then you've got a windlass battery. This is up at the front of the boat, very close to windlass, so we've got short power leads to it. And then the charging system, the alternator is charging the other batteries and is charging the windlass battery as well independently. And this is kind of a sensible system. It means you've got quite thin wires running the length of the boat up to the battery at the front, but it does mean we've got to have a third battery breaker to the windlass. The system I fitted on my boat was what I designed to be simpler, where I actually use my windlass I drive off the engine start battery. Now you might think that seems like a bad idea, but my policy is always, therefore I always have the engine running when I'm using my windlass. Otherwise I will flatten it pretty quickly. Now it's a simpler system because my alternator is charging that engine battery anyway, so there's no problem there. The disadvantage is I have to have really some very, very fat cables that run from the battery in the middle of the boat up to the windlass. So there's a big expense. I mean, we're talking really very, very big cabling to be able to take that voltage over that sort of distance. And that's the system I have in here. I've got this breaker here just to make sure I don't overload the system, but it works pretty well. The cabling, I can tell you, was extremely expensive, but for simplicity, that's why I went down this route. A bit about engine charging. There I've got my little system. You can see I've got my engine battery here, my domestic battery here. There's my little splitter that charges both the systems from the alternator. There are some very clever smart chargers around. So your alternator generally is not particularly clever, and it does sense your battery voltage, but it kind of charges not too efficiently, I guess maybe up to 80% charge. And if you're trying to get your battery supercharged, then you can buy a device such as one of these, little smart charger, and that actually is able to monitor your voltage in your battery and push it much harder. Now on my system, I don't bother to have it on the engine battery because the engine battery pretty much, it starts the engine quickly and charges up pretty much straight away. And so I've got a smart charger onto my domestic system, and basically that needs setting up. It needs to know what sort of battery it's charging, whether it's lead acid, whether it's a gel battery, because again, if you try and charge a gel battery to the same rating as a lead acid, you will tend to blow it up or set it on fire. So they're quite clever systems. You set them up, and then that actually charges the battery much more efficiently. And for me, it brings my domestic up to maybe 95%. Rather than if without it would only be maybe 80–85%. So definitely recommend some sort of smart charger off your alternator. I did actually have to modify alternator a little bit to actually make it work, but that was a little bit of excitement on the side, but it is eminently possible. So other charging systems, when I started sailing, pretty much none of these things existed, and really as a routine you would probably run your engine for 2 hours a day to top your systems up. And then came along all this variety of other systems, wind power, solar panels, and they've made a huge difference to charging my batteries up. There's pros and cons of both. I have to say that my boat came with a wind generator, which I quickly removed. That's my personal feeling. I don't like them very much. They tend to be noisy, and I always think they're potentially dangerous. They have to be mounted quite high up with these whizzing blades around, but they produce a lot of power. So if you are in a power hungry boat and you need that power, then a wind generator probably is the way to go. Worth just pointing out, not so good with downwind sailing. The greater anchor, great with upwind sailing, but downwind sailing, your loss of apparent wind means they're not going to work very efficiently. So if you're trade wind sailing, you might not get as much power from your wind generator as you might like to have done. I opted for the solar route. The solar route is not going to produce as much power as your wind generator, but I kind of like them because they sit there very passively. They just sit in the sun, and the technology has really improved a lot over the years. I've been through a few solar panels. At the moment, I've got 2 mounted on my spray hood, just like this, which I've permanently wired up the battery to charge it. And I have a folding set in 3 panels that once I'm at anchor, then I get them out, I plug them in, lay them in the sunshine, and that tops the batteries up. And I never have to run my engine. I can be anchored for a week, and I just put my solar panels out, and they do a great job and keep me topped up. Your bigger boats may well have a diesel generator, but we are probably talking of boats of at least 55, 60 foot, because a smaller boat, you just haven't got room for a generator. But something around 55, 60 foot plus, you'll often find a generator, usually diesel powered, which is great because you've got diesel for the engine. And you've got the advantage, firstly, it's knocking out 240 volts. You can run a lot of high power systems. You can run welders and electrical equipment, power tools, and it will charge your domestic batteries as well. And we also have these sort of towed generators. They come in a variety of shapes and forms, but they basically, this looks like an outboard engine, but once that's dropped in the water, the propeller is spinning and producing lots of power. The current Vendée Globe race around the world is on at the moment. Most of their boats are fitted with 1 or 2 of these because they're running some quite sophisticated electric equipment. They need a lot of electrical power, and these tow generators really do the business. So a bit of choice here. All of this equipment will be run through some sort of charge controller here, again, because you don't want to overcharge your batteries and blow them up. So with all these different devices, you will have some sort of smart charger here that basically regulates the current, so your batteries are getting optimum charge without being overcharged. Shore power. It took me a few years to fit shore power, but when I was tied alongside the marine, I realized that rather than burning my gas for my cup of tea in the morning, I could have an electric kettle, which is quite nice, or the toaster. And so it's not a big deal. All mariners will have electrical power systems. You can plug in your cable, and this goes through an AC switchboard, and you can have that wired up to certain things. My boat's pretty simple, so I actually have got a little AC system set up where it runs. I've got 3 or 4 sockets throughout the boat, which means I can plug in the vacuum cleaner or my computer or whatever I need. I purposely put these in. I've got little USB sockets in these. It's quite nice that you can plug your phone into these USB sockets as well. I do have a water heater on the boat now. Normally that is heated off the engine. The cooling water from the engine is actually giving you hot water, but it makes sense when you're in a marina not running the engine that you can heat it electrically, and that's a fairly standard fit on a lot of these water heaters here. And again, a little battery charger here, so when I'm on my boat, if I'm in the marina, then it means I can still charge my batteries just through an electrical battery charger of the 240 volt system. I have to say I went for the El Cheapo option. You can buy some very good marine rated battery chargers. This actually is just a car battery charger, but it's quite a smart one. Again, it's monitoring the battery. It does different cycles to keep your battery optimally charged. But if you buy a better known brand, Victron, that sort of thing, it's doing the same job, but basically I can have this plugged in and it's continually monitoring and keeping my battery at peak performance there. And there it is. This is the system in its completeness, and it has evolved quite dramatically since I bought the boat, which basically had 2 batteries and a manual switch on it back in the day. But I find it makes life easy living on the boat. It's nice to have the power available to you. It's nice not to have to be running the engine continuously. It's nice to have an electric windlass to pull your anchor up. And these are all systems that you can fit yourself. The one nice thing about modern age is that if you need to know how to do something, there is always a YouTube video to show you somebody else has done it before. And it's not that difficult. If you've got the confidence to do some basic electrical wiring, then give it a go. Okay, Charlie, when the house bears about 270 degrees.
Information to work out our distance from the lighthouse and use that.
We might be perfectly on track, but if we're not on time...
Have a look, I've got my phone here at the effects it has on our steering compass. So our echo sound is working, we can find a contour and follow it nicely into port.
Our left hand is pointing towards the centre of the low.